Oh, good morning, everybody. Here it is now. What is this, Sunday? Are you excited to be starting your work week? I hope. It's going to be, well, being retired, my work week is kind of boring anyway, but this next weekend coming up, I'm going to take a trip to the Grand Canyon with my wifey. So that's kind of exciting. Today, I want to talk about the scientific method, probably a little bit about the definition of science again, and then I'm going to give you an example of an experiment that Quantum Eraser, Nathan Oakley, Sleeping Warrior, all of those ball buster guys think is not a real scientific experiment. And so I just wanted to show a little bit of that. So that's what we're talking about here. First of all, let me show you a little bit from Quantum Eraser that has to do with this moon thing, and I'll let you hear that and tell me what you think of it, okay? So here goes Quantum Eraser.
Why can't I provide my idea, hypothesis? The moon is a physical object.
Wrong. Well, number one, a hypothesis isn't merely an idea. It's a supposition into natural cause and effect relationships. Number two, the moon is a physical object. Dumpster fire hypothesis is a what is numpty declaration, not a how-why natural cause and effect relationship. By the way, you'd fail 5th grade general science.
I'm just curious of why my hypothesis isn't a good hypothesis.
Look here, you big dummy.
I already told you. And scientific hypotheses aren't good or bad. They're either viable or they're not.
I'm going to tell you right now. Let's hear your natural observed phenomena.
The moon.
Wrong. The moon is not a naturally observed phenomena or dependent variable. It's a concrete noun. The naturally observed phenomena, keyword, has to be an action, i.e. occurrence or circumstance. That's why you're DOA out of the gate and is going to lead to, as we'll see, abject preposterous absurdity downstream.
Okay, so of course this is another guy that really gets angry, frustrated. They laugh a lot at this poor guy. The guy they're talking about is Leo. I don't know who that is or anything about him, but that's his name. The first thing I want to say is that Quantum Eraser, all these guys, I just don't understand that they have no comprehension of what the definition of science is. How you can, spend all these years making videos and you don't even know what you're talking about. That just beats me, It's amazing how they can go without even understanding the basic definitions, just the basic, ninth grade stuff. Then they talk about, all this other stuff about the moon. The guy, they make fun of the guy because he makes up what he thinks is a hypothesis, and then they just laugh and laugh and laugh about that. Having a good old time at Lael's expense. And that, again, is just too bad that these guys have to laugh at somebody, what's that called, an ad hom attack. I just don't understand it. But anyway, the definition of science pretty much includes the study, the observation of anything that can be observed. Now, Nathan Oakley, Quantum Eraser, all these guys think it's talking about natural things. So you're talking about, and you have to be doing an experiment. You cannot just observe something like trees. You can't go out and, measure the growth of trees or pick up leaves and try to figure out the names of these trees. To me, that's all science. I used to work in an agriculture experiment station, so I know statistics. I've been there, and I know how all this science is done. I did science for psychologists in determining test grading, which was a very interesting experiment. I did things for business college, for biologists. All of that is science. There is an experiment, there is an analysis, there's a conclusion. It's science. Okay? So don't anyone tell you that science doesn't include things that you cannot manipulate, and that it doesn't include only natural earth items like growing plants. So those are the things they think are science. They're not. Okay? So if anyone tells you that, they're just not. The second thing that they always say about science or a scientific experiment is there can only be one dependent variable and one independent variable. That's not true either. The dependent variable is the variable that you're going to study, the variable that you're interested in the outcome. The independent variables are variables that you can change, possibly, or you can measure the change, and there doesn't have to be just one independent variable in an experiment. There can be many, okay? You can look up, if you want, on Google, multivariate analysis, multivariate regression, regression of quadratic equations. Those things are all, part of the scientific method. They're part of statistics, and they're just as much part of science as the one variable or one independent, one dependent variable. That's linear statistics, and it's the very simplest kind. If you don't get into anything, intricate or, then that's the kind that you're talking about. So here I have a chart for you. hoping this shows right. On the left side, on my left, it shows the scientific method, in case you had forgotten the 6 steps of the scientific method. On the right side is a experiment that I want to go through real quick. Hopefully I can keep it short. And so that's the experiment we're going to look at just a little bit. If you want to look in depth about the definition of science and the scientific method, I made another video of that earlier. You can look that up. I think you'll enjoy it. It's not very long and explains these things very thoroughly. So the idea in this experiment, Lael said the moon is a physical object. That was his hypothesis. Well, it isn't a hypothesis because it's not testable and it's not a question. So Quantum Eraser was correct about that. However, it's not something to just hee-haw about just because it's not in the right form. What he actually was trying to say is, number one, on the scientific method, you need to have a question, an overall question. Normally, you get that question from your boss, from the research, gives you some kind of question. I can imagine, the head of a scientific research department coming to you and saying, is the moon a physical object? So you and he sit in the conference room and you discuss this. Is the moon a physical object? Yes or no? When you leave the meeting, you're going to go back to your office and begin the rest of your scientific method. Number 2 is you're going to do some research. Oh my God, flat earthers think research is watching YouTube. Well, it's not. Research is finding out what has been studied, what has been published, what is correct about the moon. It can be anything. You're going to take notes. You're going to read articles, take notes. It's not easy. I mean, if it were easy, we could just hand it off to a student and let them do it. But it's not. It has to be done correctly, and you have to have a result that you can work with. Number 3, the next thing, you have to have a hypothesis. In science, sometimes they just have one hypothesis, sometimes they have 2. The null hypothesis, H0, is generally the status quo. What is the current thoughts, okay? So H0, in this case, the moon is actually a concrete physical object, okay? That's H0. H alternate, sometimes called H1, the moon is not a physical object, but is a transparent orb or something, a light. So there are your 2 hypotheses that you're going to test. Okay? So now I'm going to come up with an experiment. The experiment is separate from all that's gone on before, but you're going to come up with how can I test that the moon is a physical object? How can I observe that the moon is a physical object? How would you do that if you were given this experiment? I'm just suggesting Quantum Eraser can think up his own experiment if it's testable. But my experiment would be to take a telescope. The best thing would be to take a telescope, or you can use a P1000 that flat earthers so much like to use, and you can look at the moon with your telescope during a time when you can say the moon is transparent. Now that, I think that's usually a time when the moon is out during the day and you hear or you see stars that look like they're shining through the edge of the moon. And so you can take your telescope and view the moon during those times. Then that's your first thing that you're going to observe, that you're going to write down notes from that observation. So you look at it totally unzoomed, zoom out, write some notes. Then you're going to zoom all the way in on the moon as close as you can zoom. Focus, be sure you're focused. Some of these flat earthers, I swear, they use their P1000 and zoom in on stars, and then it's all fuzzy and whatever, and they say, look, stars are nothing like you think they are. Well, that's because they don't know how to focus that P1000. So make sure you're in focus, you zoomed in. You can pan around and look at maybe the craters, the Mars, M-A-R, Mar, and you can look at the edge where you think stars are seen through the moon. Look at all of that and see what you see. Take notes, okay? Take notes of that. Okay. Then the second part of this experiment, on any given night when the moon is visible, you might want to do it at different phases, half moon or quarter moon. You may want to do it on a full moon. Again, take your telescope, look at the moon totally zoomed out, see what you see. And then you're going to zoom all the way in as far as you can. Make sure you're in focus and observe the moon in focus. Observe the edge of the moon. Observe the craters. Everything that you can observe, and take notes of this observation. Everything you see, everything you think, write it down. Okay, so we've written all this stuff out. Once we get this done, that's the end of your experiment. Now we're going to do some data analysis. Now obviously we don't have any numeric data, any numbers that we can crunch or that we can do statistics on or whatever. Basically all we have is notations that we took from our observation. So I want you to remember what I've said, that observation is just as much a part of science as measuring data or whatever. So it is science. And so we have our two hypotheses. If you remember, back near the beginning, is the moon physical concrete object? or is it not? Okay? Our observations, whatever the way we do the analysis, we're going to come up with one or the other of those hypotheses. Now, in science, and this is another thing that most of these flat earthers don't understand, is that in science we don't prove anything. It's not a proof that it's true. We're not proving it. We are trying our best to disprove the null hypothesis. Generally, we want, whatever it is our experiment is, to be changing the status quo and creating a new status quo. So that's the idea behind a scientific experiment. So there are two things that we can do. We either reject a hypothesis that it's not correct, it's not true, or we fail to reject. You reject or you fail to reject. Okay? We don't accept a hypothesis. We either reject it or we failed to reject it. So in our experiment, from whatever our observations were, we make that determination. Which one do we accept, or which one do we reject, and which one do we fail to reject? Okay? Don't ever say we accept the null hypothesis. That's not a correct statement. We never use the word accept. Okay? So, we've now gotten our conclusion, and then we can complete the writing of our paper, our research paper. We've written down all of the previous steps in a format for publishing, and now we can put our conclusions there for whatever. Okay? So now we've written down our conclusions, and we do this report or publish. Some of the publishing sometimes could be making a YouTube video. Otherwise, I'm sure that in a research organization, or if you've been given money by the NSF, you're going to want to publish however they think of publishing. In some publication, or if they have their own publication or whatever. That's how it's published. Now, the last thing I wanted to mention is that there's another experiment that goes right along with this. You could add this to your observations, so you could do two experiments with one set of observations. The second experiment would be, does the moon transmit its own light, or is it a reflector of some other light, typically the sun? And so that could be a second experiment. It could be a second publication, which is very good for your career. There's the old saying, publish or perish. So the more you publish, the better. And so that's what a real experiment works. That's how this experiment of astronomy, looking at the moon, is a scientific method, scientific experiment that can be performed by somebody with proper equipment. Okay? So I want you to understand that it only can be things on the earth, or it only can be natural things. None of that's true. So when you see these guys say that, you can tell them right away, David said it's not true, okay? So that's what I have for today, and we'll see you the next time around.